This is a neat little problem. It looks wickedly difficult, but I think it's actually not all that terrible. So they give you this integral defined function here, and they ask you when the function is at a minimum. So again, if you just kind of pull back and forget about what they gave you, you just think about where do we identify relative minimums or maximums, you look for a place where the derivative, where f prime is equal to zero, and then we can put together a number line and determine relative maximum and relative minimum locations. So we need the derivative here. And remember, this is the derivative of an integral, okay? And we know the second fundamental theorem of calculus tells us if you take the derivative of an integral, essentially it's going to knock out that integral. Okay, and it should just give us the function there. Now, a little bit more going on here because it's not an x up here. So it's going to be instead of e to the t squared, we're going to be putting that x squared minus 3x in place of the input there. And so it's going to be e to the x squared minus 3x. And then technically that value is being squared. That's interesting. And remember, you also have to multiply by the derivative of that inside function, which is going to be 2x minus 3. So a little bit more complicated maybe than some of these. But remember, we're trying to figure out where the derivative is equal to 0. Well, okay, so I'm going to substitute in here, and let's see what we can do. So I want to figure out when this is 0. Well, think about it. You can't take e to a power to get 0. And plus, that whole exponent's being squared, so you're not even going to have a negative exponent there, even though that wouldn't make it negative anyway. The only thing that can make this equal to 0 is if the 2x minus 3 is equal to 0. So you can set the 2x minus 3 equal to 0, and you're going to end up with 3 halves. And then we can put together a number line here. Now remember, this is f prime, okay? I erased that earlier, but we can put together a number line here and look at what's going on here. And so we've got 3 halves here, and we want to look at what's happening to the left of 3 halves, and we want to look at what's happening to the right. Remember, we want to know if the function's increasing or decreasing to determine if we have a relative minimum or maximum. So I'm going to put something to the left of 3 halves, and 0 would be to the left of 3 halves. So if I put 0 in here, I would have e to the 0 power, which is 1. That's positive. If I put 0 in the 2x minus 3, I get a negative. So to the left of 3 halves, f prime is negative, which means the original function f is decreasing. Okay, let's put something bigger than 3 halves in, and you know it can be 10, it can be 100. It really doesn't matter. But I'll put in 2 would be bigger than that. So if I put in 2 here to the 2x minus 3, I'd get a positive. If I put 2 in here, I'm going to get a positive, and so we end up with a positive. So notice f prime is going to change from negative to positive, okay? F is decreasing and then f is increasing. And what that tells us is there's going to be a relative minimum for function f when x is equal to 3 halves. So it looked unbelievably difficult, but if you just apply the basic concept, take the derivative, apply the second fundamental theorem, it actually works out not to be all that terrible.